do they eat by putting food in their mouths with their little legs? Or is that drinking?
Their mouth parts, I think they just eat, but they can carry stuff around, because she did bird seed as one of their food preferences. I mean, they would literally pick up the bird seed and try to steal it from each other. I mean, it was the most bizarre thing I've ever seen. We should have put one under the dissecting scope to watch it eat, because I'm not really sure how they eat. But they have like mouth parts and all that.
It's funny because some of them, they'll come to the edge and they'll be like, no, that's not what I wanted, and they'll back up and go back to the moist side. And some of them, they'll just go around the whole circle of the dry side just to see if it is wet. And then when I figure out, when they get back to the middle, if it's not wet, they go straight over.
That's interesting. How about yours? What do you
Yeah, mine, each one of them would take a turn going over the dry side to check it out, walk in a circle around, and then come back. And all of them have been on the wet side now for a couple of minutes, except one guy is like, I want to half be on it and be half in the middle.
Well, I got some of them toward, I guess, the outer area. They haven't moved. Like, they have just created little homes right there. They're not moving. Like, only 2 or 3 will come over here, but everybody else stays just permanently over there.
Yeah, I think when we read that article, because I'm not supposed to make copies for y'all, because y'all technically have access to it yourselves. So we're going to read it off the internet. But I guess I can post that link, and if you want to print it off before you come, you can do that. But otherwise, I'll have the laptops out for you. But yeah, it's kind of interesting the amount of time he says it takes for them to like form those little aggregates and stuff. So I think that'll be really helpful, because he kind of says how long it takes the ones he had to settle down, and that'll help you with your experimental design, you know.
And they get so mean with each other.
Some of them, they are mean.
Like, he's so small, but he's like pushing everyone out the way.
Oh, it's a little guy?
Yes, and he's just like using his antennas and everything. He's just pushing people.
Yeah, I mean, some of this would be interesting just to write up as an observation, but since we want to do statistics and all that, we've got to have something that's measurable. I won't give y'all everything I've found out about, but the practical use of these has really changed in the past few years. So maybe as y'all read, you'll start seeing some stuff. If you start getting short on finding information, including your introduction, you know, like why have they been studied so much recently? I think you'll find it interesting as y'all get into learning more about them. I'm gonna check and see what's going on with Josh. And please know, I mean, we're here till 10:30, so if y'all ever have to come late, I'd still rather you come late if you can.
Okay.
You know, than to not come.
Oh, that's so cute. He went to the corner of the dry and he just like, no, parallel park, back, no. Like he was
Yeah, they stay right at the walls too, though, don't they?
Yeah, they stay in the corner. And some of them, they just jump on each other trying to see if they can push the lid off.
That might be one way, Kendra, that you could measure. Like I was thinking, because you said you were in your light intensity. Or no, wait.
Moisture, humidity,
and moisture levels. You may end up needing to do more like, I don't know really exactly how you would measure that, but even like temperature levels. Like if we had like that bowl that gets really hot because it's clear, and then another one that may be like a frosted, but one of the old types, and then maybe compare that with a fluorescent light.
Okay.
Or something. I mean, obviously, as y'all do research, you'll come up with different ideas. But, you know, I don't know, how were you planning on measuring, like, humidity levels or whatever?
I guess the amount of wetness I could get a cotton ball. And I guess that also has something to do with temperature levels, but I was going to put various amounts of cotton balls in either side of the choice chambers. It depended on how wet they were, and keep it as tight as I can to create that buildup of humidity in that area. To see if they would, you know, go to that side. So like a really wet cotton ball to a very dry one, medium to, you know.
So you could have a dry on one side and then a wet one. Yeah, I mean, that could be really difficult to measure because, I mean, I guess you could like measure out a certain number of, like we have those little syringes and used to be over there. Like you could draw up so many, but I don't know. I mean, again, as you do your research, hopefully you can figure out if there's any research on humidity levels, but you might want to do it more on maybe like a temperature thing.
Yeah.
Because I think just putting them under the different temperatures with the light intensity being different, because we all know that fluorescents are a lot cooler than those old ones, and that one being clear and not frosted, that bulb is going to allow, I mean, you can feel the heat as soon as you turn it on.
So even like the eco bulbs they have now, you know, the ones that they don't pull so much energy, but they don't pull much energy and they don't emit so much clear light. It's just,
yeah, I don't know if like even the box, if it will tell you a wavelength that it transmits or not, but
that'd be more interesting to do.
well, I'm just thinking of something that might be easier to measure.
Yeah.
I mean, it can be tricky coming up with an experimental design.
Alright, I've gotten all my data, I think.
You got 10 minutes worth. So what was how many did you end up with at the end?
Well, just give me a second. These two will go right back to the wet side.
Oh, has it been 10 minutes?
Yeah.
Cause just do it whenever the timer is done at 10 minutes.
Okay, it's been 10 minutes, and I have 9 on the wet side and 1 on the dry. But he's exploring, and he'll be back to the wet side pretty quick. There he goes. He's like, nope, I don't like it.
Because that's the thing, because then it's like, well, if you expand your experiment out, then you've got to do that for all your experiments. You know, you've got to have a cutoff time.
Yeah. Okay. Well, no, now he's hanging out in the middle. Okay, so it's good to just stick with what's there at the 10 minutes.
Yeah.
Okay.
You really have to, because otherwise then you're introducing a bias or a new variable. Like maybe one experiment you didn't really do for 10, maybe cut it off at 8 or 12. So unless you're going to incorporate that variable into your experiment, you just need to have the same cutoff time each week for each experiment. And how much more time do you have?
Oh no, I'm finished. I'm just looking.
Okay.
I had the same as my Ash did. 1 was on the dry side and 9 was on the wet side.
Okay. So your hypothesis, Hillary, was that all of them would be. So then you actually have to reject your hypothesis, right? But Kendra, yours was that what most of them would be or something?
Yeah. I said therefore more side bugs will select the more side of the chamber at the end of the experiment.
Okay. So then you can accept your hypothesis.
And it's based on the wording.
Because she said all and you said more. Now, be aware that you're not going to say that you proved your hypothesis. One experiment does not prove a hypothesis. You have data and it supports your hypothesis. Okay? So then 3, you can answer about whether you think they orient with respect to moisture. And then you don't have to answer 4 about whether that was taxis or kinesis because, again, I don't really care. I mean, if you really wanted to study the behaviors and all that, I think you need more background to be able to do that. And then 5 is why is this advantageous? And then we're going to graph the data. So there's two ways that you can graph this. You can make, you can make a bar graph where, so you're going to write your number between the two lines so that each of these will become a bar. Or you can make it just a regular line graph so that where they intersect is your point. So,
Okay.
So where it says the independent and dependent variable, it says plot the independent variable on the x-axis. So what did we say our independent variable was?
The moisture level.
Right. So you're going to have, okay, first of all you need to determine if you want to do a bar graph or a line graph. If you're going to do a line graph,
you have two independent lines, correct?
Yeah, so you'll need to use like X's and circles. So like under wet or dry, you can put like an X for wet or circle for dry if you're going to do that. Or you can just use two different colors if you're going to do a bar graph.
Okay. What, do you have a preference between bar and line graph?
No, if you do a bar graph, you'll just need to make sure that you leave two blanks so that you'll have enough for two sets of data side by side.
Okay. I think I'll do a line graph. So that's this is each minute, or?
Yeah. Wait, well, what did you say the independent was?
Sure. The independent is the presence of moisture on one side.
So you've got, I think we're going to have to do a bar graph.
Yeah.
So we're going to do wet versus dry over time.
Okay.
So it's going to, time will be
the x-axis.
Yeah.
Okay.
Yeah. So we're going to do over time.
So, sorry, don't know what that was.
That's all right.
Okay. So, and
so we're going to make minutes. So put on this line.
Minutes?
Yeah.
Minutes.
Time and then put in parentheses minutes. Yeah, it gets a little tricky when you have to start graphing stuff.
You know, I think
You could still do a line graph.
I think I measured 20 minutes worth of time because I wasn't paying attention to how much time passed. I just was looking for the change of every minute, and I was looking at these
But yours
spaces.
was 10 minutes, wasn't it? It had to be 10 because y'all finished about the same time. It couldn't have been 20 minutes yet. It had to be 10.
Okay.
It just probably felt that way because you did it twice. Okay, so time is going to be on the bottom, and you put parentheses minutes.
Okay.
And then the number of isopods on the y-axis.
Okay.
So you can still do a line graph, but again, for the wet, are you going to do a line or a bar, you think?
I think I'm going to do a line.
Okay, so put like an X next to the wet.
Yeah, X and 0.
And
a circle.
A circle for the dry. Or you can be a solid or it doesn't matter. But so then, start with 0 and then go all the way up to 10. And so it's up to you if you want to skip lines to give it more spread out, or if you just want to do 10 in a row, it's up to you for minutes. And then you'll just plot X and Y. So if it's the same number on each side, you're going to end up with, you should have 2 lines. Because you've got wet side and dry side.
What am I doing now? Okay. So these are the minutes, and I've got.
So go ahead, label your x-axis and up to 10 minutes. And so you're only going to have up to 5 isopods. Well, I guess you can have up to 10. So go up. You only have a maximum of 10. So go up 10.
1, 2,
Do we have
3, 4.
I think you have to go together. I don't think you can skip one on that.
Yeah.
I don't think you have enough space on this particular graph.
Yeah.
Alright, so you're going to plot basically 2 lines.
Okay.
So if you picked X for wet, then how many did you have on the wet side at 1 minute?
Okay, at 0 I had 0, and at 1 minute I had 9.
Alright, so at 0 you can just do, you can put a little circle by 0, 0, 0. Because you started off.
I need you to explain this one to me.
So at 0 here, let me see your pencil for a second. You started off with 10 on the wet side, right? I mean, on the dry side.
10 on the dry side.
And then you had 0. So at 0, 0, you're just going to put a dot here. Oh wait, you use wet, I'm sorry, an X. Oh, sorry. You always look at the key. Alright, so you have an X there. Alright, so then at 1 minute, I think that's part of your problem is you did it every 30 seconds instead of every minute.
Okay.
You didn't have to do that. Alright, so at 1 minute you had 9. So you find 1 and then you go up to, sorry, where's your 1?
Yeah. This is
9
the
and put an
one.
X. And then at 2 you had
So I don't
4.
also plot the dry.
Well, I would do that separately.
Okay.
Stay with
Okay.
X's first. It
I
gets
see
too
what you're
confusing.
saying. That's okay.
So then just at every solid minute, at every whole minute,
Alright,
just
and at
plot.
2 I was at 4.
3 was 7.
7.
4, 9. 5, 8. 6, 9.
Oh, wow.
7, 9. 8, 9. 9, 9. 10, 8. And you can go ahead and draw a line if you want to connect the two.
Okay.
Let me get y'all a little.
Ruler. Some kind of screw.
There might be a ruler in here. I'll see an index card right there.
Oh,
There might be. I had some in here and I couldn't find them at the beginning of the term. I wasn't sure if I had moved them into the storage closet or what. I'll just have to let y'all use. Can use this one. So remember, only connect the X's and only connect those. Trying to figure out. Maybe I just have to put foil over the top of this, keep the moisture from escaping.
Yeah, or like coffee filter or something.
And put the coffee filter there somewhere for us. Billy, let me add these to that too.